Welcome to Honors Geometry, Lesson 7.3, Similar Right Triangles, where we're going to drop an altitude from vertex to the hypotenuse and just watch the crazy things that go on. So here we have triangle ABC. It's a right triangle. Segment BX is the altitude drawn to the hypotenuse. Watch the crazy things that go on. It's really crazy. Okay, when you pull it apart, look at that. This triangle is congruent to this triangle because this angle and that angle are congruent to each other. So angle-angle similarity postulate. This triangle is similar to that triangle because of the angle-angle similarity postulate. Actually, all three triangles end up being similar to each other when we drop that altitude down to the base. Alright, so let's see if we can get these triangles in order. The big triangle. Hold on, I gotta get my pen ready. I didn't have my pen ready. Sorry about that. Let's try again. Alright, what we got? Alright, we got the big triangle. Oh boy, it wasn't ready. I thought it was. Triangle ABC. Okay. On the medium triangle, A corresponds with A, similar to triangle A. On the big triangle, the right angle is B, so that would be X and then B. And on the little triangle, similar to triangle, okay, B has to be the one with the two arc marks, so that would be B, X, C. And because of these similar triangles, we can also make an extended proportionality statement. And I know you don't really want to do that. And I don't want to either. But you know, you could go AB over AX equals AX over BX. Okay? So all kinds of different proportionality statements we can do. You know, AX over, you know, that part with that part, that part with that part. It's crazy, yes, I know. I'll show you a couple of things that do happen later on. Right now, let's go back to Chapter 6. You guys did do some problems on the geometric mean. I never really talked about it, so I thought I would formally do it here. Find the geometric mean between 4 and 9. That is to say, 4 in the first term of the proportion, x in the second and third terms of the proportion, and that 9 in the last term. Cross multiply, x squared equals 36. Take square root of both sides. X equals 6. 6 is the geometric mean between 4 and 9. Find the geometric mean between 6 and 12. Go ahead. You go ahead and set it up and then check your work to see if it's like mine. Alright, go ahead. Set up the proportion. Alright, that's the proportion you should have set up. Oh yeah, it's pretty easy. Go ahead and solve it. I want you to put it in simplest radical form, and I want you to give me a decimal. That's right. I want you to give me both. Alright, written as a decimal, x is approximately 8.5. That's the geometric mean. Written in simplest radical form, 6 radical 2. I know you got both of those. We've already done Root 72 in a homework assignment. Alright, now let's go ahead and show some geometric means that happen when you drop that altitude. Alright, you've got YM being the geometric mean. Sorry, you got YM being the altitude drawn to the hypotenuse. That's why this is called the geometric mean altitude theorem. Altitude's been drawn. Alright, when that happens, YM is the geometric mean between the two parts of the hypotenuse. And by the two parts of the hypotenuse, I mean XM and MZ. So once again, the geometric mean would be, okay, ym is the geometric mean. That goes in the second and third spots. And the two parts of the hypotenuse, the left part and the right part. So you'll be given some numbers here, and then you can cross multiply and divide to figure out what ym is, or maybe you're given ym and you got to find both parts. Okay, that's how you set it up. And then there's a second geometric mean theorem. That geometric mean theorem says, okay, once you got the altitude, alright, let's go. There it is. Each leg is a geometric mean of the part of the hypotenuse adjacent to the leg and the whole hypotenuse. So this leg right here, xy, that's the geometric mean between the part of the hypotenuse adjacent, xm, and the whole hypotenuse, xz. So let's go ahead and write that as a equation. You would have xm, that's the part of the hypotenuse adjacent, xy is the geometric mean, the whole hypotenuse, xz. Okay, xy, that leg, is the geometric mean between or of the part of the hypotenuse adjacent and the whole hypotenuse. Alright, now I want you to do the same thing for leg yz. Write that proportion, please. Alright, you have got 2 seconds. Alright, what'd you get? I haven't done it yet, because I was expecting you to do it, and I don't think you did. Go ahead, try it. And there it is. YZ is the geometric mean between the part of the hypotenuse that's adjacent, the part, MZ, over the whole hypotenuse, XZ. And this does conclude lesson 7.3, similar right triangles.